All right, we're good now. Well, the nice thing is we haven't said anything yet. All I was doing is waiting on this to install so that I could actually use it. So let's go ahead and get started talking about functions like nothing ever happened. And let's see if this works for me. Okay, perfect. So far we've seen how you can store something like a solution here. And you could do this like, I don't know, 3 plus 4. See if it'll show this for me. Why is this? Let's come over here. Okay, yeah. Let me grab this. All right. So over here, you can see how we can store like 3 plus 4, and it should give us back some kind of like log. So if I come over here and we console log this solution like this, and let's pull up the terminal here. Oh, I'm not using this. I was going to use Quokka. Run on save for current file. Okay, there we go. So you can see how we get 3 plus 4 right here. And this shows us, this shows us the log in line here, 7. This is what Quokka does, which is one of the items I'm giving away if you join my fundraiser. I will repeat that just briefly, and that is that I have a fundraiser going right now. And if you give like at least $5 right now, I've got like 37 things to give away from Vercel and Mux, and Quokka is one of these. You can win one of those prizes and also help eradicate childhood cancer with me. This is the 4th year I've done it. You all are always so generous, and I'd love to hit our mark, but at the very least, I at least want to give away all the prizes I have from different companies that are partner with me to help incentivize you to give to St. Jude. So you can find all the links and stuff like that. You can see them around the screen here. But you can see how we could store stuff like this. But eventually, like, we don't want to have to like declare a variable for every single thing. So a function allows us to say, hey, let me pass you an item. And if I pass you 2 things, add them up together. So for instance, I could have something like, I don't know, actually, let's rename it like this. Const function, sorry, not const function, like add numbers. And here I might take in 2 values, and we'll call them A and B if I can type A and B. And then back over here, what I could do is return A plus B. Now the same exact thing should happen, except what I can do is pass add num. And what I want to do is pass along now actual values, arguments for those. So here I could say 3 and 4 or whatever, and now it'll actually pass both of these back together if I name this correct. And you see how I also get back 7. So this is way more dynamic because now I can pass in whatever numbers I want, and it adds those things together. Obviously, we'll do more complex things than basic math, but hopefully that helps you understand kind of the value of functions versus just the variables that we've talked about so far. So these functions are core to the way programming works. Thanks for your patience with the audio and all that. Also, if you could let me know if my audio video is in sync. I've had some issues with that because I've switched over to a new setup. So I'd love to know that. Okay. Most obvious application of functions is defining new vocabulary. Creating new words in prose is usually bad style, but in programming, it's indispensable. Typical adult English speakers have 20,000 words in their vocabulary. Few programming languages come with 20,000 built in. So here, they're going to talk about how you define a function. And what they're saying is you have to give these things names. And there's like an old joke that naming is like the hardest thing you do in programming. It's because it's difficult to get good names. Typically, when you're first learning, you try to like, at least this is how I tried to do it. I was like, I'm going to think of really smart names and keep them really short. Or sometimes when you get really concerned about like performance, you get like a hyper weird about how specific your names are. Generally speaking, I have always found like the more advanced a programmer gets, the more the programmer says, I'm going to name this something super obvious, and I'd rather be obvious what it is as opposed to like, as opposed to being super smart or intelligent or short or something like that. Okay, so let's define a function. There's several ways to do this. We're going to talk about this one to start with, which is to use the function keyword. We mentioned last time there are like special words in JavaScript that you can't use for anything else. Function is one of those. A function definition is a regular binding where the value of the binding is a function. Okay, you might be like, what in the world? All right. In other words, we're giving this thing a name, and we're just going to pass a function in as the name of whatever that happens to be. So we did a little bit different a second ago in the actual code editor, but you see I just assigned a variable, a name, to this function. And this function is what happens whenever I call this. And so just like we did a second ago, I can console log square, and it passes back 144. So a function is created with an expression that starts with a keyword function. That's what we just looked at. You can have parameters. These are the placeholders, and that's usually the way I remember it. Parameters, placeholders, they both start with P's. So this is the parameter here. It's a placeholder. And then inside the function, instead of referencing whatever I pass in, so I'm not going to reference 12 inside of here because it could be different. I'll just reference the placeholder. Now, once you pass it in here, we call it an argument. So those are the kind of two terms that essentially mean kind of the same thing, or they're related terms. When you declare the function, you pass in placeholders, P placeholders, for like these parameters. And then when you actually call the function, when you reference the function and try to get something back out of it or pass along values to it, these things you call arguments that you pass in. And they come in the same order you get right here. So we'll talk about that in a second if they don't, which I'm assuming they will. But all right, a function have multiple parameters or no parameters at all. And the following example, make noise, does not have any parameters. So here you say like, hey, whenever I call make noise, just console log playing. So notice here, they're not passing along any arguments. They're simply calling the function, and it says playing because that's what it's supposed to do. Now, here you have two different parameters, 1, 2, and the order of these is important. We'll talk about another way to do this if they don't, if I remember, and that is you can actually have an object, which is my preferred way because it gives you a little bit more visibility into what the function does. But here you see 1, 2. The first one they're calling n, they could call it whatever they want. The second one they're calling step, again, they could call it whatever they want. Generally speaking, I like to name these things something a little bit more verbose. So I know I'm calling round 2, but I would want to know like, okay, what does this first thing do and what does this second thing do without having to look through the entire function. So probably what I will do is call this number, and then this would be step. I think that makes sense. And then I would take number like this. And again, I would take number here. And even though this is a little bit more verbose, it's very clear what two things I need to pass in, the number and the actual step. So in this case, they round 23 to 10, and the result should be 20. Obviously, this is also getting called, so we get playing as well. So in other words, the order of these is really important. If I change this and I did 10 and I did 23 here, I'd get a totally different answer. In this case, it would return 0 to me because this doesn't work, right? So the order of these is important. So number first, step second. Some functions such as round 2 and square produce a value. You can see that that's what they've done. They returned a value. We'll talk about different ways to return out of here. Others don't, right? It's just undefined. There's nothing here. It just console logs, but I'm not getting anything back from the function. All right, some such as make noise, whose only result is a side effect. We'll talk a little bit more about side effects later, again, if they don't. A return statement determines the value the function returns when control comes across such a statement. So as JavaScript runs it, when it comes across a statement like that, it immediately jumps out of the current function and gives the returned keyword. So if I had like return up here, like hi, and I run this again, you'll notice I get hi back. It never even gets down here because all of this is ignored. Once you return out of a function, then the function's done running. All right, return keyword without an expression after it will cause the function to return undefined. So if we said return like this and didn't do anything, it'll just say undefined. So when I run the function, it does nothing, all right, and it returns nothing. Functions that don't have a return statement at all, such as make noise, similarly return undefined. Now we didn't see that because it console logs, but if it didn't console log, if it like added two things, so if I come in here, oops, we'll say something like, I don't know, let's do we need to add something? We'll just say like const hi equals 1 or something, right? So we'll do some kind of statement in this case inside of here, and I'll hit play, and now it says undefined. And this one also giving me undefined, so I get it twice. All right, parameters to a function behave like regular bindings. Actually, this one doesn't give me undefined because I don't console log it anywhere, but it would if I did, all right? In case you already know JavaScript and you're like, wait a second. Parameters to a function behave like regular bindings, but their initial values are given by the caller of the function, not the code of the function itself. So in other words, these parameters right here, they act like variables, right? Like hi equals 1 or whatever, except they just are set at their starting point by whatever we passed in. So like I passed in 10 down below, even though I think I switched it up. So that will act as 10, and this one will act as 23. And this is actually also the way you write default values for these, which we'll again look at in a little bit. Okay, so down this way, bindings and scopes. Now this can be kind of confusing. Maybe I can illustrate it in a second here as well, and hopefully that'll be a help. Looks like my audio issues got figured out too. Sorry for the rough start. Okay, so each binding has a scope, which is part of the program in which the binding is visible. So when we're talking about scope, we're basically asking, what does the program have access to at this point in its running, all right? Is it have access now, or is that value out of scope? Can it not reach out to that? And so we're going to talk about how you kind of keep stuff in scope, how you know what's in scope. This will also bring back in var, let, and const that we've already looked at before. So each binding has a scope, which is part of the program in which the binding is visible. For bindings defined outside of any function, block, or module, the scope is the whole program. These are global scoped variables. So if I were to come over here, we have this little function down here. We have a scope inside of these curly brackets. And now typically anything inside of a curly bracket, it's its own little microscope. Well, I didn't mean that for that to be a pun, but it's its own little scope. But you can also define stuff at the top level, right? So if I just say const, I don't know, like greeting equals hi, this is defined at the top scope, which means I can reference it inside of any smaller scope as well. So for instance, I could come inside here and say console log greeting, like that. Oh, just a sec. I was going to sneeze, but it's not going to happen now. Okay, so now if I were to run this, as soon as I save this, you see it says 6 here when I console log it, but notice it actually gets access to the value up here inside of this scope. So this is its own little scope, but because I've defined this at the top level, it becomes kind of a global scope. So we'll talk a little bit more about that as we go, but that's what they're saying here. In fact, they give you an example, which I should have just looked at here. You've got this one outside of here, and you've got these two inside. Now, this brings back in, like I said, let, const, and var. Before 2015, if you use var keywords, notice how even though this is inside this little block, inside this block, the scope is still global. Whereas let is block scoped, and so is const. They're both block scoped. So you kind of have a better sense of when you use something and when you don't. And this can really cause problems if you use var, so that's why people don't really use var anymore, because even though you've defined this internally, it actually also exists globally everywhere, which means anytime you use a variable name inside of a function, you can also like overwrite it accidentally. And that's something else you can do with var. You can redeclare it like this, var z equals wherever you want. So actually, maybe let's copy this over, and I'll just show you this as an example. So right here, let's grab all this. I'm going to get rid of this here. Okay, cool. So let's say we have this block. This isn't a function, but it's still a block inside of here where we're setting z equal to something. Now, I might also have a function. We'll call it something like, I don't know. Actually, yeah, let's just declare it like this. I don't know. We'll do like add or say number, all right? And we're going to pass in a parameter here. Remember, that's what these are called. We'll say like whatever the number is, we'll pass in here. And then inside here, we're going to do a couple things. We're going to define a new variable. So we'll say var, I'm using that keyword intentionally here, z equals, and we'll say something like, I don't know, hi space like that. And then in the end, we're going to console.log, and we'll take, here, let's see if I can do this inside of these kind of interpolated strings, which I think we talked about last time, but you can basically return a string with a value from a variable inside of here. And then we'll take also our number here as well. So we'll take number like this, and then I'm going to simply call say number. So yeah, so let's say number like this, and we'll just call the function. Now notice here I didn't say const function or const like say number equals function, and then so there's a couple different ways to write it. I just declared the function at the top level. And I can call say number, and notice what I get. I get hi undefined. All right, I never passed in a number, so I have this parameter, but I never passed it in as an argument. Now, this is one of the reasons why people like TypeScript, which we haven't talked about, but TypeScript is a superset of JavaScript because it allows you to say, this thing is required and it's a certain type of value. It's a number value. And so if I were to try to run this in TypeScript, it would yell at me. But I'm not in TypeScript, so let's say 3, something like that. So now it says hi 3. Now, the issue here is, let's say I want to get this value inside of here. So let's say I'm down here and I say, oh, let's console log this. So we're going to console log z right here. And notice this one says 30. Now, z over here says hi. And let's say I want to reference z itself. And maybe I even had defined it out here. So we'll say let z equals, I don't know, 2. Well, oops, I can't redefine a let. See, you can't redefine a block scope. That's what we are trying to show. Whereas with var, I can do that. So var z equals 2. So here's z equals 2. Here's z equals 30. Here's z equals hi. Let's go ahead and console log this a couple of times. So I'm going to take it here. We're going to console log it up here. I'm going to console log it below here, and I'm going to console log it in here and then down here again. So what are these values going to be? Well, at this point, what do you think the value is going to be? Should be 2, right? At this point, what is the value going to be? Well, again, we're inside of a block, so whether it's let, const, or var, you'd expect that this would be 30. What about right here? Well, now this is where var starts to cause issues. So let's go ahead and save this, and we'll see what happens. 2, 30, those are all right, but look at this. The value has been globally changed for the entire file, even though we were inside this little block scope, and now it's 30 because that's the last thing it was set to. Now I come down here. Now z has been set to high, and you see z is right here as high. Here I console log z, and notice now z is 30 again. So what is going on here? Well, var basically can reach in outside to the global scope all throughout. So anytime you define it, because I'm using this var keyword here, you'll notice how it's inside of the scope function here. Var is giving me high. Outside, we're back at 30 here again, where it's been set inside this block scope. But the function scope is kind of retaining it. So var just acts really funky. So typically you don't use var because of that scoping issue. You want to know when I'm using this variable, what is it set to? And const and let you do that a lot more predictably. Now each scope can look out to the scope around it. So if you're inside that block scope, you can reach out. So X is visible inside the block. The exception is when multiple bindings have the same name. In that case, code can only see the innermost one, right? So if you name things the same thing inside of a scope, it can only reach the most recent one. So you don't typically do that, obviously, because you're like overwriting previous ones, and you should have usually in your code editor, it'll warn you about that. So for example, when the code inside of have function returns n, it's seeing its own n, not the global n, right here, right? So if we had n defined up above here, or below here like this, it's not looking at this n value, it's looking inside. And notice because I've used let, this is scoped here, but even in a function call, it would be for var as well. So it's going to use its own parameter here and not reach out. If it looks and it can't find an n anywhere, it will then reach out and try to find something outside of it. So let's talk about nested scope. Actually, yeah, let's talk about nested scope, and then I'll see if I can illustrate this. So JavaScript distinguishes not just global and local bindings. Blocks and functions can be created inside of other blocks and functions, producing multiple degrees of locality. So different scopes inside of scopes. And again, all we're asking is, at this point in the program, what do I have access to? What does this variable mean? And so look at this. All right, so we've got this function we've defined as hummus, where it has a factor. I'm not sure why we've got hummus here, but ingredient. And inside here, I have another function. Inside of one function, I have another function where I have an amount, a unit, and a name. I have let ingredient equals amount times factor, and then I do some conditional logic here. If it's greater than 1, then add a s to the end of the unit. And then I just want to console log the ingredient amount, the unit, and the name. And then notice here, inside of the function still, I pass an ingredient with 1 can chickpeas, et cetera, right? So at each of these levels, I have this outer level. This has kind of all the outer scope. And then I have this inner function that has its own little scope inside of here, right? So this is what it's talking about, is you can have nested scope. So the code inside ingredient function can see the factor bindings from the outer function, but its local bindings like unit or ingredient amount are not visible to the outer function. So ingredient right here can obviously, this is what we're going to pass in a second here. This ingredient function, it's going to loop through these different items, and each of these are passing it in here. And inside this scope, they're kind of like scoped in. They're gated off. So set the bindings visible inside the block is determined by the place of that block in the program text. Each local scope can also see the local scopes that contain it, and all scopes can see the global scope. Okay, this approach is called lexical scoping, which is JavaScript, which is a lexically scoped language. Now, the way this actually maybe visually looks may help a little bit. So we've got this global scope. We'll just call it this. So I'll say global. And then inside here, we might have inner scopes. So maybe this is a function, and this function is called hi mom or something, all right? So we've got a function in here called hi mom, and this function may take in a few parameters, or it may have some internal variables inside of here. So let's say it has a variable name, and let's say it says name. So this is one of the things we can pass into it. All right, so I can pass in a name out here. Now, if I go and I run this function, and I pass it something else, so Again, let's say this is a function call and it can take in the name value. So this is one thing it can pass in. If I call this function and I say, hey, let me pass in a name like, I don't know, mom, all right? So I pass in mom here. Inside of here, name is the only thing that it has access to. So it looks and says, do I have a variable called name or a parameter called name? I do, it's fine. Now, for whatever reason, I didn't have name inside of here, but I had name outside in the global scope out here. And I call hi mom and it looks for name and it says, ooh, I don't have a name. Then it can reach outside of itself and it can say, do I have anything else outside of me with a variable name of name? Yeah, I do. And so it's going to pull this into the inner scope. So it always looks at kind of the small scope possible first, and then it reaches outside of itself. What that means is you can have like constants, true constants outside of in your global function that you reference when you need them. But for the most part, you want to keep things as scoped to like the smallest amount they need possible. Of course, I could have more things, like let's say I have another function over here. And let's say that this is some kind of number function, all right? So like add nums. Why not numbers? And inside here, let's say I pass in two things, A and B. So this is how I define these parameters. And when I call the function, I pass in A and B. Now inside this scope, it's going to look for both of those. So it's going to come over here. And the first thing it's going to do is look for A and say, has anybody passed me an A? And if I passed an A, it's going to use that A. And then it'll say, has anybody passed me, I guess I was supposed to do it like that. Anyhow, has anybody passed me B? And if so, it has access to that. Now, globally here, I don't have access to B or A. They're inside of this little block. So think about it almost like a neighborhood where there's this shared space that everybody has access to, but in each home, you only have access to the things you own. And if you need more, you can look outside the windows and say like, oh, does my neighborhood also have this amenity? It does. Okay, I'll use that. Otherwise, nope, I just have whatever I have in my own house. So every little section has its own. Now, of course, that means, like we saw a second ago, you can have nested functions. So maybe there's a room over here in your home, and you only have access to the variables you defined inside of your room. But if you don't see those in there, and somebody asks you, like, hey, add A and B together, and you say, I don't have A and B here, you can start by looking at your house. If your house has A and B, you're good. If it doesn't, look to your neighborhood. If it has A and B, then you're good. So this is how scoping works. You start with the smallest thing. The function looks at that smallest thing. If it doesn't have access to it, it then starts to go out and kind of look at the broader scope until it hits the global scope. And at that point, if it can't find it, then you're kind of stuck. So that's how it looks maybe more visually. Let's now give an example of how this could look over here. So let's get rid of all this junk right here. We're going to get rid of var, all this kind of stuff. Okay, so let's say like we say a number here, and I'm going to just console log, inside of here, console.log, and we'll say like we're going to log whatever the number happens to be. So when I pass this along, get out of here, it's going to do 3, right? So let's say I want to pass along a number, and I don't provide a number here. It looks in its scope, its local little scope, and says, hey, you never passed me anything. You said you were going to give me a number, and I have no number defined anywhere. So with what we just learned, what happens if I come up here and I name another thing number on a global level, right? This is at the top of the file. It's not inside of any function block or anything like that. And I get 3 here. What do you think is going to happen when I hit save? Well, it still says undefined here because it's looking inside of this and it says, okay, so here you said there was a number. You didn't pass me a number, and I actually have something defined in here that's called number. So it's still going to look at this and say, this is undefined, and I have a locally scoped item right here. So in other words, just because it can reach outside, you didn't pass the number, but you declared it. It's the same thing as like saying, let's say a const number like that, but I don't provide it a value, which you can't do with const, you can't do with let. So this doesn't have any value to it. So let's say I don't pass a number here. It's going to then reach out and try to grab this, and it says, oh, this is undefined. So I have number, but there's nothing assigned to it. That's the same thing that happens when you define a parameter. You're declaring it without any value to it. So you pass the value when you call the actual function. So let's say that I don't pass a number here, but I do define it on the outer scope. Again, it's going to first of all say, do I have anything named number internally inside this block? No, I don't. Let's look at the global scope. Let's look at the environment. Let's look at the neighborhood. I do have something in the neighborhood. It's called 3, right? This number equals 3, so that's what I can add in here. And again, if I add a number right here, now this is the same thing as declaring it like that, right? It doesn't have a value, but it is there. So it looks up and says, do I have anything called number? I do have something called number. However, it's undefined. So that's what you're going to get back. So hopefully that little clarification makes sense. I think I maybe confused that a little bit with that initial explanation. All right, let me know if you have any questions too as we go. I know there's not a ton of people watching, so it may be something later, but you can always add a comment to the video. I'm happy to answer if I can. Okay, functions as values, and we probably need to speed up because I didn't mean for this to take quite as long as it is, but functions can be kind of confusing, so hopefully this is useful. A function binding usually simply acts as a name for a specific piece of the program, such a binding is defined once and never changed. All right, so you can see like let launch missiles, and then I pass along a function. The two are different. A function value can do all the things that other values can do. You can use it in arbitrary expressions, not just call it. It is possible to store a function value in a new binding, pass it as an argument to a function, and so on. So in other words, I can store this function and call it launch missiles, and then I can pass it to something else. I can redefine it here. I can pass it along as an argument to something else. And there's a lot of good reasons to do that, which we can look at later. It's possible to store a function value in a new binding, pass it as an argument. We just looked at all that. So we'll look at all those later, it looks like. Now, there are different ways to declare it. So far, we've been declaring like this function binding. So we've assigned it to a variable name. What I was doing in my code editor is what I typically do, which is just using the function keyword and then giving its name right here. And I can just call that name. So it's a little shorter and kind of my preferred way. There's another way, which we'll look at, I think, in a second here, probably would be my guess. So here we're calling square. We can pass in this. This is an argument or a parameter. When we call it, we'd pass in an argument here, which is its number. This is called a function declaration. So we've got a function binding, a function declaration, and then we'll look at a few more in a second. The statement defines the binding square and points it to a given value. It's slightly easier to write and doesn't require a semicolon after the function. This one is subtly, there is one subtlety with this form of function definition. You'll notice here, if I come up here and try to run this, the future says you'll never have flying cars. All right, it's able to like pass this thing along. The preceding code works even though the function is defined below. So normally if you call something, you're like, wait a second, this is down here. It's calling it, remember, top to bottom. That's how JavaScript works. What's up, Fuzzy? Good to see you. But notice in this case, it actually has access to it. Well, before a file is run, JavaScript will take certain things and hoist them to the top of the file. One of those is function declarations, which is when you use the function keyword and then the name of it. This hoists to the top of the file, which means you have access to this immediately. Now, this can get a little hairy if you don't know that, both because sometimes maybe you have something named the same thing, which is not good practice, but especially if you start using things like arrow functions or function the way we saw it a second ago. What do they call that? Function bindings. Those are not hoisted. And so you can kind of get in trouble if you're used to this practice and then suddenly you don't have access to what you need. So top to bottom typically means this would need to go before this. However, even though it's defined below, it hoists it up to the top, which means then it has access to it. Function declarations are not part of the regular top to bottom flow of control. They're conceptually moved to the top of their scope and can be used by all the code in that scope. This is sometimes useful because it offers the freedom to order the code whatever way you want without worrying about having to define all functions before they're used. Typically, it's still good practice to define your functions first and then call them below. But you don't have to if you define them as function declarations. And now arrow functions, another way to write functions. There is a bunch of funky things that we haven't looked at yet, like binding values and stuff like that. So this is one of the reasons that arrow functions were brought in, really the main reason, but you can also just write stuff a lot shorter. This third notation for functions, which looks very different from the others, instead of a function keyword, it uses this fat arrow syntax with an equal and a greater than sign. Thanks, Fuzzy. The arrow comes after the list of parameters and is followed by the function's body. Now, this is a funky thing to look at first, but you will learn to love it because it allows you to write a lot more complex things, and it can help with some binding stuff that usually we don't have to worry about anymore in JavaScript, but sometimes you do in more class-based syntax. The nice thing is you can return stuff immediately out of it. So here you can see we've got a name. So it looks almost like that function binding to start with, but then you got these equals and you just pass along the parameters. There's no function keyword at all. So how do you know this is a function? This right here. this little syntax, an equal, then a parentheses, whether or not there's anything inside of it, then this fat sign, that tells you, oh, this is a function. And again, that's a little confusing as you're starting, but it lets you do some cool stuff, especially compressing items. So when there's only one parameter name, you could omit the parentheses around it. So you can just pass X like this. Other than that, you have to use the parentheses. And here you can see you don't have to have them. You can just pass it along just like this, and this is the same thing. Now, the nice thing is you can return stuff, push stuff out of the function without having to use the return keyword. Here they do, but you don't have to do that. So maybe let's use this as an example, or let's see, do we have a more complex example? Not really. I mean, I don't know that I want to use that just because then it gets kind of confusing. So let's use this. So let's come over here. We're going to say have, and we're going to pass it 4. Okay, so if I run this, I'm returning value 2, and let's console log this just so we can see console.log like that. So now it's returning 2 to us because it's having to. So this is a function binding, the way they call it. Let's turn this into a function declaration. So we're going to take have like this and pass it, and you'll notice we get the same thing. So you can also do it this way, and that's shorter already. Or we could go even shorter. Const have equals, and now we're at an arrow function like this. Now, right now this doesn't look shorter, it's slightly longer, but I'm having to use the return keyword. Arrow functions let you omit the return if you just return directly off the back of it like this. So this is kind of getting ahead of ourselves. You don't have to remember all this, but you can notice now it's a single little one-liner where I'm passing in something and immediately returning. This is called an implicit return. Usually you use explicit returns, where you do something and at the end you return something. But here you can see how right off the back of this, I can immediately return. Now this becomes really important when you start working with methods that already exist on arrays or objects or things like that. You don't have to know what that means right now. All that to say that it's really nice to be able to return immediately and then pass those values somewhere else and return off those and return off those. And so it allows you to do this in a really compressed way. And you don't even have to necessarily name this. So you can do it even more compressed inside of an area where the variable is already kind of bound. You don't have to name the actual function itself. So this doesn't work here, but like basically inside of some kind of expression or statement, you can have something return off the back of it. And essentially you can compress the whole function call down to this. So we'll see that as we go, I'm sure, but hopefully that makes sense. So there's 3 different ways to decline a function. Awesome. Favorite one-liner, const sum equals, if you can see in the chat, XYZ equals X plus Y. It's hard to see because it's so small. Nice. I like it fuzzy. Okay, so I think we got all that down. Binding scopes. I don't know how I jumped all the way up there. Okay, arrow functions. Okay, one thing about these, they are not like hoisted to the top, so that's something to kind of keep in mind. At least I don't think they are. I think it's the only thing. Yeah, there is another issue that's a little odd, but basically they do the same thing. There are more ways to write the same thing for now. That's all you need to know. All right, let's talk about the call stack. And I saw that we were talking about this, so I grabbed a couple example things that I think will be helpful. This is basically talking about okay, we've talked about how functions or files in JavaScript run from top to bottom. Let's now talk about how, inside of functions, how things are called, in what order, and that kind of thing. What actually happens with the flow of the program. If you go step by step by step, what does that look like? All right, so let's take a closer look. Here's a sample program that makes a few function calls. We have a function we've declared called greet, and we have to pass in who, which is a variable, which looks like it should be a string. So we can greet Harry, and then we console log by after this. So in what order will these things happen? All right, let's go ahead and see. Yep, as we might expect, it first does this, but notice it doesn't just read this. It actually executes everything inside a function, and then it goes to the next line number 5. So it goes step by step. So if we look at it more schematically, it would look like this. It reads the function greeting, right? I'm not sure what not means, not in function. Oh, it's just saying it's not in the function yet. It's now in the function greet. It's now in the console log. It's now in greet. It's not in the function. It's in the console log. It's not in the function. That's kind of confusing the way they wrote that, all right? Because the function has to jump back to the place that called it, when it returns, the computer must remember the context from which it happened. In one case, console log has returned to the greet function when it's done. In another case, it returns to the end of the program. The place where the computer stores all this context is called the call stack. So JavaScript has basically like a list of items, like a to-do list. And that's called the call stack, where you can set things on that and say, hey, well, I'm going to do that. And sometimes it'll execute it right away. Sometimes it'll say, well, I got to do the next thing first, and then I'll come back, and it ticks it off in the order it puts it in. Storing this stack requires space in the computer's memory. And JavaScript handles all this for you. All you have to do is basically know that there is an order to these events to make sure that you're writing stuff in a right order. If you run out of space, or you're not intelligent in the way you run your program, you can run out of space. The following code illustrates this by asking the computer a really hard question that causes an infinite back and forth between two functions: chicken, egg. All right. So if I were to run this, maximum call stack exceeded. So it tries to do this, and as it keeps running, it messes it up. So what's happening? Well, I call the function chicken. It reads this and runs this. But notice what we're returning here: another function. And because these are function declarations, this thing has been hoisted to the top, so it has access to it right away. It runs one, and it returns chicken. What does that do? It calls chicken, which calls egg, which calls chicken, which calls egg, and it just keeps going back and forth. There's no end to this, right? So this is when we run out of memory. All right, so we'll look at this a little bit more. In fact, I had some examples because I thought they were going to talk about it more, but I did not do that. So maybe let's do that real quick now. You can actually visualize this. This one's a little confusing, but notice how we're like going A, B, C, and D. And if I run this, it'll actually evaluate the script, and we can kind of step through this. So it sets log A on the call stack. If I do step, notice it logs A, it puts that on the task queue and logs it. Then it gets rid of it. So it does all this, then it does this, then it gets rid of it, cleans it up, and then we go to the next step, which is it logs B, it logs C, it logs D. So notice it's actually like logging these, and there's actually more complexity than just a call stack. There's a task queue, there's a micro task queue as well. So now it's going to log D, then C, and then eventually B as well. And that's because of the way that we ran these things. So we have a timeout, which we haven't looked at, and a promise and all this. So it's going to log A first, then it's going to set a timeout here of 0 seconds. So it sets this kind of behind. This is why it's confusing, because we don't know about a lot of these things yet, but this is a way of delaying items. This is also kind of a way of delaying items and saying after something happens, then do something else. And this is just at the global level too. That's why we got A first, then we got D, then we got C, and then at the very end, we got this B being logged out. Like I said, is a little confusing just because you don't know about a lot of that yet. But I did have another one. I think it was this one right here. Get out of here. All right, here. So we've got this function. Oh, this is using jQuery. I didn't notice that. Anyhow, don't worry about it. When we click it, basically what it's going to do is set a timer. And then after 2 seconds, it's going to run all this. So if I click it, save and run maybe. Okay, so it clicks it. It then runs this. It sets it on the call stack. It then runs it. So it kind of does this one thing after the other. I thought this thing had better examples. Anyhow, that's just showing like it goes through a sequence, and it depends on how you delay stuff or time stuff or if you're waiting on something. So JavaScript has to kind of order stuff for you because it's all single threaded. So it's going to do it all in one order, but it has to kind of set up a to-do list for itself. You don't need to know exactly how it all works now. Just know that that is happening. So sometimes you need to give that some thought. All right, we've also got optional arguments. So we've got here this x, return x times x. So notice I'm passing 4. This is the only parameter it defines. But I pass random other things like true and hedgehog. Well, JavaScript is intelligent enough to say, I don't need these things. You can pass them if you want, but I'm going to ignore them, and it does. So if I run this, it should give me back 16 right here because it's ignoring true and hedgehog. They don't do anything, so you can pass along additional ones. You can also, or the downside of this is possibly likely even that you'll accidentally pass the wrong numbers to arguments in functions like this. So A and B. If B equals undefined, then return negative A, I guess. Else return A minus B. So here we're actually doing like a little check inside of here, I think is all they're showing. I mentioned a second ago that you can pass in starting values here. So if you don't want to pass in a step every time, you just want to make it optional, you can have step equals 1 inside of the parameter call, which not only declares the value, the binding of step, but it gives it a value as well. And it says it should be equal to 1 unless I pass something else in. In this case, it overrides it. So maybe let's actually grab this and jump back over to the code. We'll add this in here. Here we've got round 2. We've got n, which is a number. Again, I would probably call that number, so I know what it does, and step. You can set this to 1 to start with. So that way, if you don't pass something in, it should still work. So you'll see here, I should get 5. Why is this thing not running? Can I do this? Okay, there we go. So I get 5 showing right here, and down here I get 4. Now, the reason is because I passed in 2 right here, the step I want this to be. Whereas here, 1 is going to be defined as the step automatically. What's going to happen if I get rid of that kind of default starting point for step? Well, notice this one says not a number. It can't do the calculation because it requires both, right? It requires I pass in something like 1, which gives me back 5. So step here, I can define this automatically. Let's say it's 1, and let's say I define this number as well. I could say something like 4. What that means is I don't even have to pass this in at all. I could just call round 2, and notice it passes back 4, where it takes n as 4 and step as 1. So you can set default values, and then you don't have to pass them in. The function should still work. Usually, it kind of depends on what you need. Usually, you try to say, like, if I really need this thing to be a value, then I'm going to just make the person pass it in. The person being you or somebody you're working with, you'll make them pass it in as an argument. But sometimes there are things like steps or other items like that you might say, you know what, it's almost always going to be this, but I still want to give them the power to override it if they want to. And that's what this does. So you can have optional parameters. And again, the order of these things matters. So before, you might remember earlier we said, well, you can optionally pass in stuff that you may not need. So I could say like true and like, I don't know, or what was this? I guess this should be an actual Boolean, true, and then like hedgehog. So you could pass these in, but the issue here at this point is that the second item I passed in is going to be here for step. It's going to be in its place. So it happens to work with the calculation we've done here, but it wouldn't normally. Now there are ways you can like bypass an item that you're passing in, but all that to say the order matters. So this true is actually what's being dropped in here for step. So the order does matter. In fact, if I were to do this, this should break, right? Because I can't pass in hedgehog in the place of step and the math still work. So the order matters. Even though you can pass in optional parameters, it's after the number of parameters you can pass it. All right, let's talk about something really quickly before they get into closures, because this can be kind of confusing. I mentioned that a while ago. A lot of these things I'm adding are just kind of bonus things that you'll get around to. So right now, just be like, oh, cool, I'll come back to that later, and that's totally fine. But instead of passing them in like this, where they're like kind of the top level of the function, you can also pass in an object like this, and you can pass in step. So let's get rid of this right here. Now the advantage here is that these things both now have a name to them. So n, now I can say that this thing equals like 5 or whatever, and then I can say step equals 1. So the advantage here is they're named, and you can do them in any order you want. So I could say, let's put step first, and then step equals 1 and n equals 0, and it sorts it all out itself. So typically when things get more complex, I like to have this object I pass in that contains all the values I need. And then when I call it, I pass it in an object, and I have to actually name the things, which helps me when I'm actually looking at where I've called it to know, like, what were the things that I had to pass in? What do they have to do? And the nice thing, too, is when you hover over these in a VS Code or VS Code forks, it actually tells you what these things are. You need n and you need step, which is really, really helpful. You can also do command or option spacebar, and it shows you the same exact thing in VS Code. So see how much clearer it is what I need to pass in versus that, right? So this right here, unless I happen to have the function here, which I may have it in the same file, but a lot of times you're importing it, and I say round 2, what does this number do? What does this number do? I don't even know what these things do. I'd actually have to click inside of here and look at that, and then be like, oh, the first one's the number, the second one's the step. So by passing in an object and naming the things, when I go to call it, it's very clear what these things do. And by the way, whenever you're like looking at a function in VS Code, at least, you can hold down the command key and click, and it will jump to that function even if it's in a different file. You can also hold down the command key and look at it, and it actually shows you those items as well. So that can be helpful as well, and you can actually see the full naming here. You can see what it does. So there's a way to get around that with VS Code and other code editors that show you that automatically if you just hold down command and look over that. But I still kind of like the object passing in an object because it's really, really clear what you're doing. Okay. JS is a basket case of a language. Totally true. Fuzzy mentions having default argument parameters is really handy when setting up a recursive function. That is true. Where you do the same thing, keeping track of the index, which I think we're going to look at recursive functions in a second if we haven't already. All right, closure. This is the ability to treat functions as values combined with the fact that local bindings are recreated every time a function is called. It brings up an interesting question. What happens to local bindings when the function call that created them is no longer active? So basically we've got here this local variable n, and then we return the actual variable here. So we're returning the actual binding to n, whatever that thing is we passed in. So what happens at this point? All right, so if I hit play, you'll see I get 1 and 2. So I wrap the value 1, I pass this in, now n is assigned to 1, and now local is assigned to n, and then I return this function with local. So now local at this point, when I actually console log this, it's returned to me as 1. That's the first thing I passed in. Now if I wrap it here the second time, right? Now I've changed to 2. So it's basically saying what happens to local as I continue to pass this along. That's a little confusing the way I described it, but hopefully it'll get clearer as we go here. This is allowed and works, and as you'd hope, both instances of the binding can still be accessed. So you can do wrap1 and wrap2. Notice they're both calling the same function, but I can call wrap2 down this way because it kind of stores this in memory, right? Because I've assigned it to a variable. This feature, being able to reference a specific instance of a local binding, is an enclosing scope called a closure. You're not going to use this a ton to start with, but it is important to know that if you pass back something from a function like this, you still have access to the inner scope. So we've been talking about scope, and we defined it as like these neighborhoods, right? You've kind of got these neighborhoods. The whole neighborhood has access to everything in the global scope. Then a house might have access only to what it's in its scope. Maybe you have a room here. It only has access to what is in its scope. Man, I can't talk today. However, if you call this and you return something like B out of it, now you'll actually have access in the outer scope to something in the inner scope. So you can kind of this is basically a way to think about scope in in the reverse way, right? So instead of reaching outside, if you call something and you return from it an inner scope, you can now get access to the kind of the inner scope inside of it. So it's a way to kind of reverse the scope if you want to. It gives you control to do that. So this down here, this explicit local binding from wrap value example isn't really needed since the parameter itself is a local binding. So there's other times where this is helpful. Like let's say you're keeping track of a specific score. And if you pass something into that function, you say every time I give you a number, go ahead and return to me a score. And you can have that one score function, call it several times, and have different scores you're keeping track of for different games. Maybe we can look at an example, but basically what it means is you can reverse scope. You can say, actually, I want to be able to look inside of a lower scope and get a value out of it. And if that lower scope returns you that value, you can do that. And so it gives you control to kind of go both ways. Recursion, speaking of Fuzzy's comment, this is really helpful to have default values in recursion. It's perfectly okay for a function to call itself as long as it doesn't do it so often. It has no eject, right? So it has to have an eject. This is called recursion. Now, for the most part, people recursion breaks people's brains. I have a friend who loves recursion for some whatever reason. That's totally fine. You can do that if you want, but you can see here we've got the function called power. We're going to pass in 2 and 3. That's going to be exchanged here. Base will be equal to, exponent will be equal to 3. If we're going to say if exponent equals 0, return 1. Well, that's not going to be fired. So then else, do this. Base, that's 2 in this case, times power, that is its own function, and I'm going to pass in base and exponent minus 1. So if I run this, it's going to go through this multiple times until it finally returns a value right here, right? Well, not right here. yeah, it'll finally return its final value and kind of eject out of this. This is rather close to the way mathematicians define exponentation, and arguably describes the concept more clearly than the loop we used in chapter 2. Now, there's one thing to note about this. Let's see if they mention it. Yeah, it's a lot slower than using a for loop. So you typically don't do this unless you need to do it. But there are plenty of times where you need to do this, where you actually say, like, for instance, we haven't really looked at DOM trees yet, but if I were to look at the DOM tree, inside here, maybe you're inside this section down here, and you want to just keep looking up and say, I'm going to start at this A section, and I want to look above me. Do I have a body above me? Nope. Okay, well, then I want to look at a body above this. Nope. Do I have a body above this? Yes. So sometimes it's easier to do a recursion you kind of almost need to do, where you look up, what is my parent? Is it a body? Nope. Okay, then call it again. What is my parent? Is it a body? No, then call it again. And then eventually you kind of exit out of it. So it is slower than a for loop, but oftentimes they're needed. The dilemma is speed versus elegance. And recursion often is about elegance and making it easier to read, even though, like I mentioned, a lot of people find them confusing. Worrying about efficiency can be a distraction, especially as you're learning. Right now, just get it to work, and you'll find better ways to do stuff. If you're still writing code the same way you did 2 years ago, then we have an issue. But right now, just say, how can I make this work? Think through the logic. And it's okay if you use syntax that later on you might say, that's kind of dumb. I shouldn't have done it that way. All right. It's not always inefficient alternative to looping. Some problems are easier to solve with recursion, especially really nested issues here. These are often require exploring or like processing several different branches, where the for loop is not really meant for that. It's kind of meant for a kind of a straight thing. Okay. So here's an example of that. Find solution. Inside here, we have another function called find. So this is where kind of that branching thing happens. And then we'll probably call one of these or both of these. Yeah. So find we'll call again here. Find we'll call again here. I'm not going to go through this. This is fairly confusing if you're just getting started. But basically, we're calling this find multiple different times inside of here, depending on what's happening. Here, they're even using that ternary that we looked at earlier. Well, I guess it's not a ternary. They're just saying if this doesn't exist, then call this. So it's a nullish coalescing operator. So this can get kind of confusing. But basically, you're constantly recalling itself until you get the answer you want. It's not necessarily the shortest sequence of operations, but it makes sure that you get the answer you actually need. And like I mentioned, it's okay if you don't understand how this works. Just know that you can call functions inside of themselves as long as you have an exit strategy. The inner function find does the actual recursion. It takes two arguments, the current number and the string, and records how we reach this number. So that's what find is doing. And if it doesn't find it, so if it's not equal to target, or if it's greater than target, then these two things happen. Otherwise, it keeps trying to locate how we found that solution. And it keeps calling itself to do that. So this is the actual sequencing of it. If you want to look at that, go for it. I think that's probably a little too much right now if you're just getting started. Okay, so we've learned a lot of things. Let's kind of recap. We've learned there's several ways to declare a function. We have this function declaration, which we looked at. You can also bind something like round2. And you can set this binding to equal a function like that. That also works. Or you could do what's called an arrow function, where you get rid of this, and you just return this as an arrow function like this. So those are different ways to write a function. The only real difference that you need to worry about right now, at least, is that this function declaration is hoisted, not hosted. So you can put it down here, and it will still work, because it will hoist this to the top of the file, kind of like in its memory. It'll first say, what functions do I have available to me? Push those to the top, and then you can run them. So that's one thing to kind of take note of. We've also learned about parameters. These are the placeholders. Placeholder, parameter, both start with P. That's how you define these variables inside of that function scope. And then arguments, which are the actual times that you call the function, you pass those in. We've learned about scope, where you've got global scope, anything called on the outside here. So const name, if I can type, name equals Chris. So this is a globally scoped item. And then you have inner scopes, which are inside of these curly brackets, essentially. And by default, you look inside the inner scope first. And if you can't find it there, it goes to the next scope. Can't find it there, it goes finally all the way out to the global scope. And if you're running this inside of a web browser, there's actually a bunch of stuff in that global scope that you didn't even put there. It's just put there by the web browser. So it can also look for stuff like that outside the global scope. So those are most of the things we've looked at. We've looked at the fact that you can pass in a function as an argument. So like I could pass in this case, this wouldn't work because I'm not expecting a function. But if I was, I could pass in like round 2 to round 2. Now it's going to break everything here, but you can pass in that. We've looked at recursion where it can call itself multiple times. We've looked at closures where even though I don't normally have access to remainder, if I were to return a function that gives me access to this, then I could have access in the outer scope to something that normally would be scoped to the inner scope. A lot of this we'll look at multiple times as we go through this book, so it's okay if like the first time you get it, you're like, I couldn't do it myself. If you understand it conceptually, that's kind of the important stuff. Okay, growing functions, and then I think we're getting fairly close to the end. There are 2 more or less natural ways for functions to be introduced into programs. The first is when you find yourself writing similar code multiple times. So this is basically saying like, when should you be writing a function? So when you do things multiple times, that's a good clue to say like, I should write a little factory that'll do this for me. We don't like to do stuff multiple times. That's kind of the origin of a lot of people's coding journeys is they say like, why am I doing this over and over again? Isn't there a way to tell the computer to do this whenever I give it these 2 numbers or something like that? So in other words, if we want to write a program that prints 2 numbers, the numbers of cows and chickens on a farm with the words cows and chickens after them in zeros, like that, all right? So you could, of course, just write this yourself, right, as a string. But you might want to say like, oh, actually, I want to pass this in depending on how many cows or chickens I have or whatever. Well, that's when it's a good time to say like, why am I hard coding this multiple times? Well, let's write a little function to do this for me. I'm not going to go through the example because I think here all they're saying is basically like, when should you do something? When should you write a function? When you see things that are happening multiple times. They are going to show you a couple like things where you can like pad. There's a better way to do that, but that's okay. They're trying to keep it simple right now. Let's talk about functions and side effects, and then we'll look at the summary and maybe do an example. I think they've got a couple examples that I haven't looked at yet, but functions can be roughly divided into things, into those that are called for their side effects and those that are called for the return values, though it's possible to have both side effects and return values. So a side effect is basically something the function does, but it doesn't pass back to you. So it might alter something, and you want to know that. What was the other one? A return value is the value you get back, right? A pure function is a specific kind of value producing function that only has no side effects, but also doesn't rely on side effects from other code. So usually, the more you write JavaScript, the more you want to keep things as pure functions. They do one exact thing. Once you start to make things super complex and they rely on other values outside, they change values outside of themselves. It just gets really complex. So typically, you want a thing that does one thing. So a lot of times that means the smaller the function, the better. Not always. Let's see. Fuzzy is saying a couple things. Yeah. Pay attention to Fuzzy. I love how they put in a while loop early days. I know, right? Nobody really uses that, but that's fine. This was refined last year too, or revised last year. So, okay, so we've got the summary here. We'll look at this side effects thing in a second. Should I do something now with this? Maybe I should. All right, so let's come over here. Let's change this to a let so we can change it. And let's say like inside here, right now this is essentially a pure function. It takes in some values, but it doesn't rely on anything in the global scope or the outer scope, right? It takes in values and it just returns to you this bare number. However, if we want a side effect in here, we can come in here and say, actually, now I want name to be equal to like Joe or something like that. Now, as soon as I do this, my name, can I do this? This should, yeah, okay, there we go. So my name equals Joe. I've actually redefined something in the outer scope. And since it's a let variable, I can do that. The trouble is, now this has a side effect. I might be just trying to round numbers and I forget, ooh, this does something outside of that function. It's not a pure function. It actually is going to reach outside and change some other value. So if I were to come up here and we console log my name, like that. Up here, this would be Chris. However, if I come down this way, it's Chris down here, and inside here, it's going to be Joe, right? So it's got like this internal binding here, so it just kind of messes stuff up. This is probably not a great example because it doesn't actually change the value here. to my name at this point. Well, it kind of does because basically, I don't want to get too complex, but basically it is changing this value. It's logging it directly in here. And because of the call stack, the actual log here still says Chris, but don't worry about it. But basically, I have this side effect where I'm changing something outside of it. That's not a pure function. That has side effects. So typically you want to avoid those or just at least know when they're happening. All right, so let's look at the summary, which is how we should start. That's how I started last time. But yeah, this chapter taught you how to write your own functions. The function keyword, when used as an expression, can create a function value. When used as a statement, a function declaration, it can be used to declare a binding and give functions as its value. Arrow functions, this is confusing. Basically, you can assign it to a variable. You can use the function declaration, which we've looked at, which hoists it, and then you can also use an arrow function. That's all they're saying, okay? A key part of understanding functions is understanding scope, which is really, really true. Each block creates a new scope, each of those curly bracketed areas. Parameters and bindings declared in a given scope are local and not visible from the outside. Bindings declared with var behave differently. So don't use var, basically. Separating the tasks your program performs into different functions is helpful. You don't have to repeat yourself as much, and functions can help you organize a program by grouping code into pieces that do specific things. Now, notice here they don't talk about closures. They're not talking about call stack. That tells you how important that is to you right now. If you know how to do this, that's kind of what you need to know. And just keep in the back of your mind, if you start to run into issues, there's something called the call stack that's going to order stuff in certain ways. There are closures where it can return and kind of reverse the scope. And right now, obviously, they're showing by their summary that's not as crucial. It's just knowing that they exist. Okay, let's look at this. Some of these exercises, perhaps. The previous chapter introduced a standard function math. This comes built into JavaScript that returns its smallest argument. We can write a function like that ourselves now. We define the min function that takes two arguments and returns their minimum. All right, so here's a min function. We're going to write our code here and return out of that. And we should get these two values. So let's come over here. Okay, that's a separate one, right? Yeah, okay. So let's come over here. We're going to eventually want to call this thing, right? So let's define it up here. So we're going to say, let's just use an arrow function because those are, well, let's use a function declaration. So we'll do min. It's going to take in two values. I can see that. So we can say like number 1 and number 2. These are my parameters, and I'm naming them, but they're not set to anything yet, right? They're not initialized with any value. So inside here, then I want to basically say like, which one of these is smaller? Well, remember, I can return from our last lesson, we learned math.min, and I can just pass in num1 and num2. Oops. So it should give me back whichever one is smaller out of those two. And I guess let's console log this in here. Oops. Just so we can kind of see the actual values. All right. So I passed in 0 and 10. 0 should be the smallest. 2 and 10, 2 should be the smallest, right? 12 and 10, 10 should be the smallest. So this function now, which I don't really need to do this because math does this for me already, but you can see how I have written a function that returns these two things. So that's the first example they give you. Recursion. Actually, it's kind of getting late. Be counting which one of these. If I only do one more, we can do the recursion. That's fine. And then I probably should go. I didn't realize how late it was getting. We've seen that we can use the modular operator, the remainder operator, to test whether a value is even or odd by using this. All right. Another way to define this, whether positive. Here's another way to define whether a positive whole number is even or odd. 0 is even. 1 is odd. For any other number n, its evenness is the same as n minus 2. So define a recursive function is even corresponding to this description. The function should accept a singular parameter, a positive or whole number, and return a Boolean, true or false. Test it on 50 and 75 and see how it behaves on number -1. All right, so we're just thinking positive numbers right now. Is it saying I can use this or saying it not to use this? Let's see. The function will likely look something similar to the inner find function, recursive find solution. Okay, that's not super helpful. I'm not actually sure if it's saying I should use this or should not use this. I'm assuming not because it wants me to write a recursive function, maybe. All right, so let's see if I understand what it's saying. All right, is even. This is going to take in one number. And I think what it's saying is I can check to see, I can use the modular operator. I think that's what it's saying. So like if num, actually let's just call this num because I only have one instead of num1. If num modular by 2, then I want to return, well, how would this be recursive? I'm not understanding how they want me to do this. Yeah, because that's, I think maybe it's saying not to do that. So n minus 2, 0 is even, 1 is odd. I'm not totally sure how they're wanting me to write this as a recursive function. Like you wouldn't normally do it this way, so that's, I think, why my brain is maybe breaking on this, so I don't know. So I guess we'll skip that one because I don't understand what they're asking us to do. Somehow they're asking us to recall is even and pass like a number back in. So I don't know if it's saying like check first if it's 1 or 2. That makes no sense. Like you wouldn't normally do this. Like if it's 0, it's even. If it's 1, it's odd. So if num like equals 1, is that what they're saying? Then return false. Else, or here we'd say like if num, maybe this is what they're saying, is equal to 0, then return true. And then otherwise, I just recall is even. Maybe that's what they're saying, minus 1. Let's see, min, what is this? Is even. And I'm going to console log this. I think that's what they're saying. Undefined is even. Let's see, if this equals 1, if it equals 2, otherwise num minus 1. Why would this thing be undefined? So let's pass this in. No, 2, 0 should be true. If it's equal to that, return that. If it's equal to that, do I have to return this? Yeah, so I have to return it, sorry. So then I'm returning out of here to recall, and it just keeps running this over and over again until it finally gets down to the end, although that's not the right answer. Everything is false. Clearly, my brain is breaking on this. Like I said, recursion doesn't work for everyone. I don't understand what they're wanting me to do here, so I think I'm just maybe misunderstanding that. Maybe this needs to be else. Oops. And then this needs to be else. Again, like you would never do it this way, so yeah, I don't know. I must obviously not be understanding what they're asking for here. So, but anyhow, they're trying to get you to somehow call the same number. I just don't understand what the ask is. Okay, so we'll call that it for now. Hopefully that was useful to walk through all that. I know that this can be kind of overwhelming when you're getting started. I'm probably at the stage too where I should look at these things ahead of time and work through myself just to make sure I kind of know where we're going. Because several times here I'm like, are they going to talk about this? Are they not? And I've kind of just been walking through these live with you. So I might start doing that. The next one I plan to do is on Friday. I will remind you that I've got things like Quokka.js that I've just been showing off here available on this fundraiser. If you give at least $5 and send it to me by the end of September, right now I have like 37 donation incentives to give out, and I have like 7 people or 6 people have given me their actual information. So I don't have enough people to give these things to. So if you give $5 right now, you're guaranteed to basically get one of these. And I say that every year, and every year there's like maybe 2 people who give who don't get something. This year right now, I'm going to have lots of things I just can't give out. So anyhow, I'd love to have you join me in helping defeat childhood cancer. You can see more at the link down below. But yeah, I enjoy being able to use the channel for something other than just coding. It's fun to be able to actually give back some. Well, thanks so much for following along. I hope that was a help to you. I am going to close stuff off now. Sorry for the issues at the beginning with audio and all that kind of stuff. Hopefully everything is nicely lined up. Yeah, you enjoyed that. So thanks so much. I'll catch you next time.